architecture. Now the same way the production architecture will be much more complex. So the production architecture, if you see, production and DR will have exact same architecture. Let's see the production architecture, how it goes on. Normally what you have is, this is a structure, isn't it? So you have a browser that you use to hit the application. So here you will say http://icicibank.com. That's what you are doing. So http://icicibank.com. When you have such things, so then you have DNS stuff, then you have set of routers. All right, the routers will take you to a firewall, then architecture that we always talk. Then you come across a load balancer. So the load balancer, what we see in is F5 load balancer. That's what we say. F5 is from company Big IP. The general architecture that we always talk. Then you come across a load balancer. So the load balancer, what we see in is F5 load balancer. That's what we say. F5 is from company Big IP. Big IP is the company, F5 is the load balancer. Now after the load balancer, we usually say there is a web tier. So you have a web tier, means you have Apache servers. So we have Apache servers. This is an Apache. So let's look at, assume that each of these Apache, so these boxes are, these are boxes. So in production, just say, in non-production you don't have Apache servers, guys. Remember that. Only in production we have Apache servers. So in non-production you will test it only once, not much. So only once in a while, because the Apache is static content. Just say that you have one in QA, you test it only once. Where otherwise you directly, the testers are going to directly test. Whereas here in production you have boxes. So you have box 1, box 2. These are all for Apache servers. Now assume you have box 3, box 4, then 3, box 4, then box 5. So assume 5 boxes you have, and on each box you have a Apache server. 3 Apache servers are running on each box. That's how you're going to say. So total 15 Apache instances are running. Now all these 15 instances are standalone instances. Sometimes you get a question, what if an Apache server fails? Can you fail over the request to another Apache server? We can actually put these Apache servers into a cluster. There is a Apache cluster also, but to keep it simple, just say that these Apache servers are standalone servers. They are not in a cluster. If at all they ask, if the question is like, what if Apache fails? You just say we can put it in Apache cluster. But do you have an Apache cluster? No, we don't have an Apache cluster. So you're going to do it like, you will look at the document and do it. Now after the Apache server, so you have 15 Apache servers. All the 15 is what are in the load balancer. So the requests basically land on the Apache servers from the load balancer. Now the question is, what if the load balancer itself fails? So basically the load balancer can fail. So you have a fail safe for load balancer also. It's not just one load balancer you have 2 load balancers. So that if one load balancer fails, the other load balancer can actually take care of the request. This is also another load balancer. Then you have like this. Let's say you have a box. Now in your environment, just say you have around 100 JVMs. Now when you have 100 JVMs, our general idea is, I'm going to draw the boxes like this. So 100 JVMs you have, And when you have 100 JVMs, obviously you're going to require a lot of boxes. Let's say this is one box, this is second box. Now in such a box, you have one admin server, the first box, and 3 managed servers per box. Now say you have 15 managed servers in a domain. So you basically, for 15 managed servers, how many boxes you're going to require? 3 each. So you will require 5 such boxes. So this is box 3, box 4, box 5. So these boxes together are forming the first domain. 15 servers, 15 JVMs. One admin, 15 managed servers. Just say all these 15 managed servers are in a cluster. Alright. So put these servers also into a cluster. That will sound nice. So you have a hybrid cluster. A hybrid cluster in the sense, a horizontal cluster is multiple boxes or different boxes. A vertical cluster is all servers in the same box. Whereas you have some of the servers in the same box and other servers in the different box. So you are using a hybrid cluster. Now you have one domain, 15 JVMs. Alright. Now say you have 15 into 7 such domains. Means you have domain 2, so like this, you have domain 2, domain 3, domain 4, like this. Domain 2, domain 3, like this up to domain 7. So how many each domain having 15 JVMs. So the total number of JVMs you have in prod is 15 per domain multiplied by 7 such domains. So you have 105 JVMs. All the 105 JVMs have the same application. You have only, let's say you are supporting the same applications which has 10 archives. Only one application, 10 archives. Alright, 7 of them, or let's say 6 of them are WAR files, 4 of them are AR files. You deploy all the 10 archives to all the JVMs. And how you do that? You use shell scripts. Shell scripts to deploy. That's how you're doing, or you do it, you check it from console. Now this is not done yet. So what you are doing here is you have 105 such instances. Now in a production environment, usually you will have hardware level clustering also. Means if this box goes down, we don't depend on the WebLogic alone to handle the load. So we will have a mechanism wherein if this box goes down, somebody else will actually handle it. Now that is usually done by what is called a Veritas cluster. So each box you are looking at, so let's say this is box 6, this is box 7, this is box 8, this is box 9, this is box 10, let's say. Now these boxes, basically you won't just leave it to the fate that this box will fail. The boxes will fail. Now you know the boxes will fail, and even in spite of knowing the box will fail, if you're not doing anything about it, then it's stupid. So we don't leave things like that in production. So what we do is, or we don't do it, what the Unix system administrators do is, if this box fails, we have another box. Now usually the box failure is because of hardware failure. A RAM could fail or a motherboard could fail, a chipset on the motherboard could fail, or some battery failed. So hardware related failures. And the storage that we have is usually network storage, which means the storage is centrally connected to each of the servers we are looking at. So it's connected here, 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 like this. So what we have is each box has its own CPU and RAM, but the storage is common. It's not like we are using our regular desktops where you have its own individual hard disk. The hard disk is a common storage. It's called network storage. The network storage basically is connected everywhere. So if this box failed because of whatever reasons, all that we have to do is execute the start managed .sh or start mng11.sh on this box, because the same file system is visible on this box also. So what we have is we need somebody to monitor whether this box is available or not, and that's usually done by what is called a Veritas volume manager. So you have Veritas volume manager. So when you say we have 105 JVMs, around 105 JVMs, these 105 JVMs are spread across 7 domains, each domain having 15 JVMs. All the 15 JVMs are in a cluster, and each box has 3 JVMs, and each of the box is in a Veritas cluster with another box. So here you have box 11. Now Veritas cluster is, this is a software. So you have Veritas software here, Veritas software here. This is called node 1, node 2 of Veritas. 1 of Veritas, this is node 2 of Veritas. The node 2 is called passive node. Node 1 is called active node, means that's where the processes are running. As long as node 1 is available, node 2 is pretty much empty. It's not doing anything at all. It's empty. Means there is no work for node 2 at all. If the node 1 fails, the Veritas volume manager software is installed on both. So the node 2 will detect that node 1 has failed, and it will execute all the commands that we have configured. Like when the Veritas is configured, this happens during the initial phases of project. So the system administrators are going to ask you, we are setting box 6 and box 11 in Veritas cluster. If box 1 fails, what are the scripts you want us to execute on box 11? If box 6 fails, they're going to ask you, if box 6 fails, what are the scripts you want us to execute on box 11? They're going to send you a mail. You'll simply say, I want start mng11.sh to be executed. The same way, I want start mng12. Like that, you give a list of scripts that you want to be executed. So if box 6 went down, the servers on box 6 went down, but all the servers were started automatically on box 11. So you will have a slight downtime, means during the time the startup is happening. During that time, these servers will not be available. Then they will come up. And when this transfer is happening, the host name of box 6 and box 11 will be same. So for the other servers, when these guys are talking, when we are configuring listen address, we don't usually use the IP of the box. Instead, we use the host name of these boxes. And these two boxes will have the same host name. So when other servers are trying to reach the managed servers, they don't even know that there is a failure. That's the beauty of this entire setup. So you have in production 105 JVMs, and how many boxes you got now? Look at the boxes you have. So 105 JVMs, and you got by 3 because each box is having 3. So that will take you to 3 3s 9 and 3 5s 15. So 35 boxes you got. Now obviously all the 35 boxes are in a Veritas cluster. So you have plus 35 Veritas nodes. Veritas passive nodes. So you got 70 boxes in production. Alright. Now come to the JVMs. So JVMs we already calculated. Boxes we have calculated. Heap size. Heap size we have for admin server in production, it will be double especially. So you will have 1024 for admin, for managed servers 2048. You may get a question like, why only 2048? Why not 3 GB or why not 4 GB? You'll simply say we are using 2048 because Oracle has recommended us 2048. Right then, if we have 2048, so let's say how much RAM is. These settings are both XMS and XMX, guys, by the way. The same 1024 is for XMS and XMX. Here also 2048 is XMS and XMS. Like that. Alright. Now after the heap sizes, what you have now is the RAM on the boxes. Now let's look at the RAM. This box, for example, if we take, this is running 4 JVMs. How much is the memory we need for 4 JVMs? These are 3 managed servers, which each one taking 2 GB. So 6 GB for managed servers, 1 GB for admin. So 6 plus 1, 7. And then 2 GB for the OS. 7 plus 2 GB. 9 GB is what we need. If 9 GB is needed, another 9 GB should be free. So 18 or 20 GB per box. This is production. In non-production, you won't have 20 GB. And what is the CPUs? What about CPUs? How many CPUs you will require? You require, because you are running 4 processors, 4 JVMs. Other servers are running only 3, but still we are calculating based on 4. So go ahead. Means even if something is still remaining, it's okay. So CPU, you have a quad-core processor. So on each server, you have a quad-core processor. So that's your setup for production. Now the exact same setup is there for DR also. Exact same setup. So when there is a disaster, what actually happens is, the router configuration will be changed and it will be sent to a router of DR, because the routers will also have IPs, guys. So let's say the router IP is 10.2.3.4. Alright, this IP is 10.2.35. These are 2 routers in production. Now that's what is reflected in DNS. Both of these can be actually combined and be called with single router also. Now in front of these 2 routers, these 2 routers are updated here. They're called name servers. So what we do is, if there is a problem in production and if there is a DR, let's say the DR IPs are 1, 2, 3, 10 and 11. The DNS will be updated with 10 and 11. So the traffic will directly go to DR. So this setup will not receive any traffic because this will not be there anymore. See, by the time Chennai is gone, means the load balancers at Chennai are also gone. All the boxes are also gone. So DR setup is at Mumbai. Mumbai IPs are 10.2.3.10 and 10.2.3.11. The 10.2.3.10 and 11 will be updated in the DNS. So when somebody hits ICICI Bank, the request is directly going into Mumbai servers. So that's how is the number of servers you are supporting, the number of boxes. So if you look at the overall setup, 105 is production, means another 105 in DR. So 210 JVMs. Then how many boxes? 70 boxes in production. Another 70 boxes in DR. So 140 boxes. Heap size is same. RAM is 20 GB per box. So the number of JVMs you are supporting total, if you say look at this figures. Non-prod, you are supporting 50 JVMs across 20 boxes. Each box having one admin and one managed server, other box having one admin. Now production, when it comes to production 105 JVMs, you always say approximately, guys. You don't exactly say like we're supporting 105 JVMs. It's not like the way. You say, okay, we are supporting 105 JVMs. You should act like you are thinking and telling it. It's not like you mugged it up. All right. Then 105 JVMs, how many boxes you are supporting? Because there is a Veritas cluster, 35 plus 35. So in DR, how many you are supporting? Again, 105 JVMs and boxes, 70 boxes. So total, you are supporting 50 plus 105 plus 105. So 300, 350, around 350 JVMs you are supporting. That's a very nice number, isn't it? So you are working basically on a very big environment. It does not mean that you are going to look at the log files of all these 350 JVMs every day. The same way, look at the number of boxes. 720, 70, 70, 140 plus 20, around 160 boxes. Now, obviously, when you say such a big environment, you will be asked how you are monitoring it. You will say nicely, we are using Introscope, or we are using OEM, Oracle Enterprise Manager, to monitor these things. So what do you monitor? You know that. You know the list of 10 items that you monitor and how they look like on the dashboard. All right. So these are the areas that these are the capacity that you are monitoring. All right. So let's store it. Excellent. Now going back to a couple of other things that we may have left. So we have seen the architecture of non-production. We have seen the architecture of production. The capacity planning general guidelines, I just told you. All right, for heap size is 2048, recommended by Oracle. You'll say it's in production. 1 JVM per core, 50% of total RAM should be free, 3 JVMs per box. And these are the assumptions that we are making. Now, our calculation of the number means we said 105 JVMs we are using, but how did you decide you need 105 JVMs? There should be some calculation. As you said, we nicely said we are using 105 JVMs. So, who decided you will require 105 JVMs? Somebody has to decide, isn't it? So here, if you say, you decided 105 JVMs. So these JVMs, who decided that you will require 105? Now that is again a simple calculation. And now for such a calculation, you are going to assume a base testing. What is baseline testing is, you start your testing with basic assumption. Now these are the assumptions. What are your assumptions are? I'm going to have the JVM heap size 2 GB. All right, 2048 MB. This is the heap size I'm taking. I'm going to deploy the application and I'll see how many requests it's going to handle. So I'll perform a load test on it. So what essentially I'm trying to do is, I have taken a box. All right, I set up a domain, WebLogic domain. Then I have set up an admin server and then a nice managed server. The managed server I have taken 2048. All right, 2048 XMS and XMX, both same. Then I have deployed the application on top of it. I started the testing. So I started running load runner on it. So I'm running the load runner. These are the basic assumption. The basic assumption is all that's it. The heap size is 2048. I'm having 2 processors on this system. 50% of the RAM on the system is free. That's my basic assumption. I started testing it. Now, a load runner, we know that it can increase the load continuously, constantly. So you go on increasing the load. So let's say you have tested it for a couple of days and you constantly started to increase the load like this slowly. As the time increases, you started increasing the load. Load is nothing but you are performing a manual thing automatically, like login. Login, if you perform manually, the same thing can be done by the tool. It's basically 1,000 users logging in at the same time. Right? Slowly, next day 2,000, next day 3,000, like that you will perform. You take it to such a level that this server breaks down. Let's say at 10K requests, your server crashed. If 10K requests your server crashed, you know that, okay, for 2048 MB, it can take 10K requests. Then you go to the customer and you say, okay, we have tested it. We have seen it, all right, 2048 is a recommendation. So each instance can take 10K. Now you are going to ask the customer, how many requests you are expecting? Let's say the customer says, we are expecting 1 lakh requests at peak time. If 1 lakh requests are expected and each JVM can take up to 10K, how many JVMs you will require? 1 lakh by 10, which means 10 JVMs. That's your calculation. Or in other words, let's say the JVM was able to take only 1K. See, it all depends on what kind of request it is, guys. See, not every application is same and not every manager take the same number of 1K requests. So when somebody takes, tells you what's the load on your server, if application 1, if this JVM is able to take 1K requests of app 1, it does not mean it can take 1K requests or of app 2. It all changes from application to application. Now assume that this JVM is taking only 1K, but you are receiving 1 lakh requests, then you require 100 JVMs. And there is one more thing. We know that this will crash at 1K. So when we know it will crash at 1K, obviously you're not going to send 1K requests, right? You will send only 70% of the requests. So the 100 itself is the exact number. So you're going to have at least 30% more than, because you won't send 1K requests. You won't wait till it crashes. You will send only 700 requests so that it is decently occupied and it's performing fine. So 100 itself is not a final number. So you need to add another 30%. So 130 JVMs is what you settle for. Once you have decided the number of JVMs, then the rest of things you know. You go by the assumptions. So you say, you go by these assumptions. You basically say you have decided 130 JVMs I need, each JVM having 2 GB. Then I want to put on 3 boxes, so 3 JVMs, so 130 JVMs, 3 JVMs per box. So how many boxes I'll need? 130 by 3. Then what is the RAM on each of the box? I know. Alright, how many processors I need to put? I know. Heap size I've already said. That's how you decide the capacity. Means the capacity planning has to be done after a load test. It's not done randomly. So when questions are asked, how many servers you are supporting, what are the environments you are supporting, your answer is, what are the environments you are supporting? Let me go back to question here. What are the questions we're supporting? I think this. What are the environments you are supporting? The environments you are supporting are, QA, UAT, LT, pre-prod training. You have 2 sets of non-production, then you have production, and then you have a DR setup. These are the environments you are supporting. How many servers you are supporting? When this question comes in, don't say like you marked it up. Now you start calculating. you start act like calculating. So like, let's say you're going to say, okay, non-production, we have 5 environments, and each environment is having 1 admin and 2 managed servers spread across 2 boxes. So 5 such environments. So per environment we have 3 servers, 5 such environments, so 15 JVMs in non-production. We have 2 such sets of non-production, so 15 plus 15, 30 JVMs, and another 10 we are creating and destroying, so 40 JVMs in non-production. And when it comes to production, we have 7 domains, each domain having 15 managed servers. So 15 by 7 will make 105 managed servers plus 7 admin servers we have. So we have talked about only managed servers so far, admin we left. So 105 plus another 7. So let's say 110 JVMs in production. So another 110 JVMs in DR we are supporting. So 200 to around 300 JVMs we are supporting. That's what you said. Now when you say it like you are calculating it. And again, you tell about the architecture. These JVMs are spread across multiple boxes, and all right, each of these boxes in production especially is in a Veritas cluster, and there are 70 boxes. So you make it look like a very big environment. You always say that you are busy. We don't say we don't have any work, and they are not going to take you. Alright, then you see what is the load on the server. You will see the load basically means how many requests you have on the servers. When a load is being asked, just say that at peak levels we have around 350 instance, 350 sessions per instance. Say that number. You can say any number, doesn't really matter. You just saying is what matters. So let's say here you say the load on your system, just say around 350 to 400. That's how you say it, like you are thinking about 300 to 350 to 400 requests per JVM. So the 350 to 400 are on your backend. On Apache, you may have another 50 more because there are static content requests. And what's the size and max size of the JVMs? Then in non-production you have 512 and 1024. 512 is for admin, 1024 is managed servers. Then in production you have 1024 and 2048. The max size changes from 32-bit and 64-bit. For 32-bit, 3 GB is the JVM heap size you can give. For 64-bit, you can go up to 16 GB. Space. All right. Now, apart from what's the command to find the version? Now, we already discussed about the version find related stuff. So you should be able to now answer the question. Now, the answering question is you need to make it look like it's really nice. Means you are calculating, you are thinking. You need to act a little bit. All right. So make sure you are calculating those numbers. That's really important. All right. So well done. Good job. Go ahead and repeat it one more time. All right.